Hello. This is our Sunday review sheet, our worksheet here for today. This is going to be about elimination, some of the stuff that we had talked about yesterday. So, hopefully, this helps you. I'm going to go through a few of these and hopefully clear up some misunderstandings, and then you'll be able to finish the worksheet for today. Okay, so let me get rid of my ugly mug. Peace out, ugly mug, and let's get started. So, I'm going to go over a couple from this first section. Remember, right now, we are focused on using elimination. Now, as we're using elimination, I made sure I broke this section off. This first section is elimination problems that would use addition in order to eliminate. Remember, the idea of elimination is that through putting these equations together with add or subtract, that we eliminate one of the two variables. Okay, that would be the goal. So, let's look first at number one. Okay, so for number one, the things I notice in number one immediately is the x variables, okay, are opposites. Okay, meaning the top one is a 1x and the bottom one is a negative 1x. Okay, what's important about that is when I see opposites, that's what helps me see that I can use addition of these two in order to eliminate one of my variables. So what I know is if I add these two equations together, I'm going to eliminate the x's. So we have 1x minus 1x, that would be 0. Then with our y's, 2y plus 1y, that would be 3y. And 27 plus negative 1, 28 plus negative 1, that would be 27. Okay, now from here, then I'd be able to solve the equation. So right now, notice I don't have an x in this, I just have 3y equals 27. So I solve the equation just like we learned last semester. Divide both sides by 3, and I believe the y variable would be 9. Now, how do I figure out the x? Now, in order to figure out the x, I'm going to need to plug it back in. And I'm going to choose one of the two original equations. So, for this first one, I'm going to go ahead and choose the top equation. Now, when I choose this top equation, I'm going to plug in the answer that I just figured out. I just figured out that y was 9. So I'm going to put a 9 in place of the y. I don't know why I keep, guys, I apologize. There we go. Sorry, I had put 29, it's supposed to be 28. Okay, now, 2 times 9 is 18. And then I would solve this equation. Subtract 18 from both sides, that means x would have to be 10. Okay? Now, to make sure this does really work, I would plug in both of those and see if it works in the other one too. Okay, so, if I check it with the top, x is 10, y is 9, 2 times 9 is 18, 10 plus 18 is 28, that works. On the bottom, this would be negative 10 plus 9, and that does equal negative 1. So I plug it back in, I can test to make sure that it does actually work for both of those. So my answer here as an ordered pair would be 10, 9. Remember, we put our x, then our y. Okay? Now, next one I want to do is number 3. Okay? So for number 3, when I look at that particular problem, what I notice is that the y's end up being opposites. Okay, so what I notice is I have a negative 3y and a 3y. And I know if I add those two numbers together, I'm going to get 0. Okay, so for this particular problem, I'm going to add the equations together. Negative 9x plus 5x is negative 14x. Negative 3y plus 3y is 0. Negative 15 plus negative 27 is negative 42. So I would have negative 14x equals negative 42. Divide both sides by negative 14, and I have x is 3. So I have one of my answers. I'll plug it back in. I'm going to use the top equation. And you can choose either one, okay? So you can choose the one that you want to choose. X is 3. So I'm putting a 3 in where the x is. And then I would solve this equation in order to get my answer. So this would be negative 27 minus 3y equals negative 15. So I would add 27 to both sides. That's going to give me negative 3y equals 12. Divide by negative 3, and y would be negative 4. Okay, so to check it, I'm putting 3 in for x. Negative 9 times 3 is negative 27. I'm going to put negative 4 in for y. Negative 3 times negative 4 is positive 12. And yes, that does equal negative 15. Okay? For the second equation, negative 5 times 4 is negative 20. 3 times negative 4. Excuse me. This has been a rough day. Okay. My x is 3. Negative 5 times 3 is negative 15. My y is negative 4. 3 times negative 4 is negative 12. And negative 15 plus negative 12 is negative 27. So I'd get 3, negative 4. Okay. Again, make sure you put in your x answer, then your y answer. Okay, so that's how we would do our elimination problems using addition. Okay, now, our next type is our elimination problems using subtraction. Okay, so the key difference here, now look at number 7, okay, is notice with the y's, I have the exact same number. Okay, so I have a 5y and a negative 5y. Okay, those are the same. So we do want to subtract. Now, I am always a little leery of just writing my subtraction like this because I'm always afraid that I'm going to make a mistake. Okay, so typically what I would do is I would rewrite that bottom one, and this is going to be a negative 7x. That's going to be a negative 5y, and that's going to be a negative 29. Now, the only reason why you do that is because I have an easier time doing these problems when I can just combine them. Okay, so now, notice I have opposites. I can go ahead and combine these. This is going to be negative 17x when I do that subtraction. That's going to be 0. And that one's going to be negative 34. Okay? Now, I solve the equation. So from here, I'm going to divide both sides by negative 17. And I'm going to get x equals 2. Now, once again, just like before, once I get that answer, I'm going to substitute it back in. Okay? I'm actually going to use the bottom equation. And it really doesn't matter, you just got to make a decision. So I'm putting 2 for the x. I'm solving that equation. 7 times 2 is 14, plus 5y equals 29. So I would subtract 14 on both sides. That leaves me with 5y equals 15. Divide by 5, and y would be 3. Okay, so I believe the answer is 2, 3. Now the only way to know for sure is to plug it in and test it. So negative 10 times 2 is negative 20. 5 times 3 is 15, and that should be negative 5, and that is correct. We do the same thing here. 7 times 2 is 14. 5 times 3 is 15, and that does equal 29. Okay, so I know for sure that I did the problem correctly, okay, because it works for both of those. Okay. Let's look at number 8. Okay, number 8. So in number 8, once again, when I'm looking at the problem, I notice that the y's have the exact same value. So those are exactly the same. Okay, that means I'm going to use subtraction. Now remember, just like I did number 7, I usually I'll modify that equation so that I don't really subtract, if you notice on that last one. So I am doing subtraction, but I like to rewrite it. So we have 3x minus 4y equals 13. So if I subtract negative 5, that's actually going to be the same as adding 5x. If I subtract negative 4y, that's going to be the same as adding 4y. And if I subtract, there we go, subtract 21, there we go. So I revised it, and now I can do this problem. So 8x plus 0 equals negative 8. So 8x equals negative 8. Divide by 8, and I get negative 1. Okay. Now from here, I need to plug it back in. And I'm going to go ahead and choose the top equation. So I have 3x minus 4y equals 13. My answer for x is negative 1. Three times negative 1 is negative 3. And then I'm going to solve that equation. So I'm going to add 3 to both sides. It's going to leave me with negative 4y equals 16. Divide both sides by negative 4. And y is negative 4. So I believe the answer is x, negative 1, and y, negative 4. The only way to check that is to plug it back in. So x is negative 1, so 3 times negative 1 is negative 3. Y is negative 4. Negative 4 times negative 4 is positive 16. And that does equal 13. If I test the other one, negative 5 times negative 1 is 5. Y is negative 4, so negative 4 times negative 4 is positive 16, and 5 plus 16 does equal 21. Okay, so I know for sure that I'm getting that correct. Now, I'm going to do one more of the subtractions just because I know historically these tend to be the harder of them. Okay, so let's go ahead and look at number 9 together. Okay, so for number 9, what I should notice is that with the x's again, with the x's this time, notice those are the same. So if those are the same, I want to use subtraction. Okay? Now, as you've seen me kind of change this problem, I want you to notice, again, I'm going to write the top one because I'm not doing anything with that. But with this bottom one, when I'm subtracting them, notice I'm just changing these signs. So like If I'm subtracting 4x, that's going to be a negative 4x. If I'm subtracting 5y, it's going to be negative 5y. If I'm subtracting 17, it's going to be negative 17. So I'm just showing what I'm doing, and now I can just put these together. 4x minus 4x, that is 0. Negative 4y minus 5y is negative 9y. And negative 28 minus 17 is negative 45. So I have negative 9y equals negative 45, and I solve the equation. So y is going to be positive 5. Take that, let's plug it back in. I'm going to choose to use the bottom equation, the 4x plus 5y equals 17. I just wanted to use that one. I know the answer for y is 5, so I make sure I put that 5 where the y is. And now I solve. So I have 4x, 5 times 5 is 25, equals 17, and there's my equation. Minus 25 on both sides. I get negative 8, divide both sides by 4, and x is negative 2. So I would get negative 2, 5. Plug it back in and test it, and I'm going to go a little quicker with the test. 4 times negative 2 is negative 8. Negative 4 times 5 is negative 20, and that is negative 28. 4 times negative 2 is negative 8. 5 times 5 is 25, and negative 8 plus 25 is 17. Works. Okay, so that is for sure my answer. Okay. The only other types of problems that are on here, on the third page, are these evaluate problems again. Okay. So I'm going to do number 13, and then I'm going to leave the rest of them for you to do. So number 13. Remember, we give the function. What you're going to notice, the similarity between this is there's going to be a lot of substituting in and figuring out answers. So for f of 6, remember 6 is an input value. So I'm going to plug 6 into the x. And now I type that in a calculator. Negative 2 times 6 plus 6, and that would give me negative 6. Okay, so f of 6 is negative 6. Letter B, f of negative 9. Now the only thing that's going to change is now instead of a 6 for the x, instead of a 6, I'm going to put a different number there. So it'll be negative 2 times negative 9 plus 6. Negative 2 times negative 9 is 18, plus 6 is 24. Now, letter C is different. This one says find x if f of x is 17. Well, f of x, we know, is 17. So instead of writing an f of x in this location right here, I'm going to change that. So this problem, to figure out, I'm going to go 17 equals negative 2x plus 6. And when I solve this, I'm going to be able to get the value of x. So minus 6 on both sides, and I get 11. And divide by negative 2. Excuse me. And my x value is going to be negative 5.5. Now, for the last problem, it says true or false. F of 6 is greater than f of negative 9. Now, nice thing for this one is we already did those. F of 6, we got negative 6. F of negative 9, we got 24. And then I look to see if that's true or false. So those outputs, this is saying that -6 is a larger value than 24. That is a false statement, okay? It's not written right. Okay, so that is review over our function notation. Okay, so this video is on your Canvas page. If you need to re-watch specific problems, help each other out, and make sure this is turned in, at least for my class. Okay? Have a good day. Sayonara, arrivederci, ciao, hasta la vista.